So I have everything that's given, what I need to find, the reaction equation. So I'm going to start with my two volumes. They're given to me in milliliters. We're going to convert them into liters because our molarity is always units of moles over liters. I know the actual concentration of the sodium hydroxide, so with the volume and the concentration I can find how many moles of sodium hydroxide did we start with. Then I can relate that to the moles of HCl with the ratio. In this case it's 1 to 1, but even if it were 1 to 2 or 2 to 1, you'd get that from the reaction equation, and you could apply this through. And once you know moles of sodium hydroxide, find the moles of the acid. And then we know the moles of HCl. We know the volume that was given to us is 10 milliliters, so we can put moles of HCl over the liters of HCl and get our final molarity of that acid solution. So now we're just going to go through that conceptual plan using the actual numbers, multiplying or dividing, canceling out any units we don't want. So the first one, again, we're given the volume of sodium hydroxide we needed to titrate with. We're going to convert that into liters, divide by 1,000 or multiply by 1,000th. Should be 0.01254 liters of solution. We multiply that by the molarity. So in this case, liters cancels out. We'll be left with moles of sodium hydroxide. Should be 0.001254 moles of sodium hydroxide. Apply the ratio. Again, units cancel. This time we lose moles of sodium hydroxide, and we'd be left with moles of hydrochloric acid. So 0.001254 or 1.25 times 10 to the negative 3 moles of HCl. So now we know how many moles of acid we have. We know our volume. We're just going to put moles over our volume in liters, and that'll be the end. So again, we're given our volume of acid in milliliters. We divide by 1,000. We get our volume in liters, 0.010 liters of HCl. And then for the molarity, like I said, moles over liters. So we take moles from the previous slide, put that over the volume of the acid solution, not the base, because we're looking now specifically at the acid, and we'll find the molarity of our solution, 0.1254 moles. And if you think in terms of the ratio, I know that I took 12.54 milliliters of that sodium hydroxide solution to neutralize the acid. The volume of the acid was slightly less than that of the sodium hydroxide, 10 milliliters versus 12.54 milliliters. So since it's a 1-to-1 ratio and it required a greater amount of base to titrate that acid, it makes sense that the acid is slightly more concentrated than the base. One last practice problem. I'll talk a little bit about the quiz, and hopefully this will catch everybody up. So now we're asked, what's the concentration of sodium hydroxide solution that requires 27.5 milliliters to titrate a 50 milliliter sample of 0.1015 molar sulfuric acid? So again, we know what our acid and our base are. We're going to write out the reaction equation. Here's our acid, sulfuric acid, and our base. We're going to form sodium sulfate and water. And when we look through this, we need to balance it. We see that what we actually have here is a 1-to-2 ratio between our acid and our base, meaning for every mole of acid we have, we need 2 moles of base to neutralize it. We're given the volume of the acid, 50 milliliters, and its concentration in terms of molarity, moles per liter. So this is our known solution. This is what's going to go in our burette and titrate against our base. With the base, we know our volume, but we don't know the molarity. We don't know the concentration. So from here, we can determine moles of acid, relate that to moles of the base, and find our final molarity. So again, we're given volume and concentration of the acid and just volume of the base, and we need to find the concentration of the base. Same kind of conceptual plan we used last time. We know our ratios, 2 to 1 for the base to the acid. We're going to go from milliliters to liters of the acid. We're given milliliters, but we want liters because molarity is always moles per liter. Once we have the volume of the sulfuric acid in liters, we can multiply by the molarity. The volume term will cancel out. We'll be left with moles of acid. We can relate that to moles of base, divide that by the volume of the base, and find the concentration of the base in moles per liter, or molarity. So first step, again, we transfer in that 50 milliliters of our acid to liters. So I divide by 1,000, 0.05 liters. We're going to do the same thing with the base. We're given that as 27.5 milliliters. We're going to divide by 1,000. The volume of our base is 0.0275 liters. Now we take the volume of our acid, we multiply by molarity, moles per liter. We'll see the volume term again, the liters cancels out. We'll be left with moles of sulfuric acid. We have to multiply by that by the ratio of base to acid. Or again, if you think about the units, we want to cancel out the acid units and be left with the base units. So however many moles of sulfuric acid I have, I multiply by 2. That gives me moles of sodium hydroxide. 0.01015 moles of sodium hydroxide. Now once I know the moles, I already know the volume, we converted that into liters, so all I have to do is get the desired units that I need for molarity, or moles over liters. So I just put moles of sodium hydroxide over the volume, that gives me the molarity. So it makes sense that the sodium hydroxide is much more concentrated than the sulfuric acid. It actually takes twice as much or twice as many moles of sodium hydroxide to neutralize that sulfuric acid because of the stoichiometry. So even though we had a lower volume of sodium hydroxide than the sulfuric acid, our concentration actually needs to be a little bit higher. That's everything here for titration. Again, I want you to kind of understand the concept, what the equivalence point means, what an endpoint is, what an indicator is, and looking at the equations here. They're not a lot different than the solution equations or solution stoichiometry. We're just taking one known solution in terms of its concentration, its moles, its liters, the volume, and relating that to another one within the reaction equation. So we'll need to know everything now for Chapter 4, looking at giving the quiz Tuesday, November 8th. 5 questions is normal. Anything from Chapter 4 is fair game. Go ahead and email me with any questions you have. Hopefully this was helpful. That's it. Bye.